Hello students, we will continue this discussion on Chapter 3, the laws of probability. The first law we have is called the addition rule, sometimes referred to as the union of events. The key word in this section is or. Just going to circle that here. Or, and it uses this symbol, the upside down or the U symbol. Basically we read that as calculate the probability of A or B occurring, and it'll be written as that symbol there. So right in here, the probability of A or B occurring. This is the formula for it. Right in there. Oops. Probability of A plus the probability of B minus the probability of that upside down symbol. This basically is the intersection of two events, the joint events, what they share in common. Remember our discussion of Venn diagrams? If you had two circles or two sample space that overlapped, that is the intersection or the joint events of those two probabilities, in this case A and B. So there is a review question on page 46 that we'll go over. It talks about two events. Event A is two dice with that when you roll them they total at least 10, so 10, 11, or 12. And B, the probability or event B being defined as two dice that you roll that total being an odd number. And we want to calculate the probability of A occurring or B occurring. Or in the rare event, both of them could occur. So let's erase this from our last discussion in here. So we have the probability of A. A is being defined as two dice being rolled that give you a total of 10 or more. So how many outcomes are there with two dice? So this is what we did in the first section of this chapter. So two dice, six-sided dice, here's the two dice, we multiply outcomes. So two dice are going to have 36 outcomes. Knowing how many outcomes there are enables us to determine probability. So event A, as I said, is two dice that give you a sum of 10, 11, or 12. So this is something we just got to jot down. So we could have the first dice being a 4, second dice being a 6. That gives us a total of 10. We could also have first dice being 5. The second dice would then have to be a 5. And we could have the first dice being 6, with the second dice needing to be a 4 to give us a total of 10. We could also have, in order to calculate 11, we would have the first dice being a 5, second dice being 6, or first dice being a 6 and the second dice being a 5. To get a total of 12, basically only happens one time. Both dice have to be 6. So basically this tells us that there are 6 different ways a total of 10, 11, or 12 could occur. We know that there's 36 outcomes possible, so the probability of rolling two dice and getting a total of 10, 11, or 12 is 6 out of 36. Event B is defined as an odd number. Well, you roll two dice, they're either going to be odd or even. So this is split right down the middle. There's 18 different ways it could be odd out of a total of 36. Likewise, 18 ways they could be even. So we want to answer this question here. What is the probability of A? Ooh, what happened there? Ugh, I can't handle that. So 1 second, let me just do some quick erase. Let's just delete that. Not sure what happened there. Okay, so now we want to calculate this, the probability of A or B occurring. Here's the formula, the probability of A plus the probability of B minus what they share in common, the joint or the intersection of those two events. Sometimes we can only know the intersection or the joint probability when we draw things out. Sometimes that information is given to us. So the probability of A is 6 out of 36. The probability of B is 18 out of 36. And then we subtract what they share in common. What they share in common we can only tell from, in this example, because we listed out these probabilities here. So how much of these probabilities, of these outcomes right up here are odd? Well, we have this one, 5 and 6. We have 6 and 11, or 6 and 5. I'm sorry, totaling 11. The probabilities for 10 and 12 would be even. So here we are subtracting out 2 out of 36. So this gives us an answer of 22 out of 36. You may want to simplify that, turn it into a percent. It's okay. On the exam, this answer would be correct. As is, you don't have to simplify it. Now, just a word about why we have to take account for taking what they share in common. The values here, 5 and 6, right in here, and 6 and 5, they're counted in A. In B, this is all the odd numbers. A dice of 11, basically a dice of 3, 5, 7, 9, and 11. Those are all outcomes where the dice are going to show odd numbers. With the 11, this can only happen when we roll a 5 and a 6 or 6 and a 5. So they are counted there again. So that's why we have to take out what they share in common, because we are in essence counting those values, counting the roll of 5 and 6 or 6 and 5 twice. We'll go on to a different example that'll highlight this as well. We have this scenario. What is the probability of rolling a 3 or a 5 on one dice? So let's determine rolling a 3 is event A. So the probability of A will be 1 out of 6. B, let's change colors here. Rolling a 5, we'll call that event B, so we can calculate the probability of B is also 1 out of 6. What's the probability of rolling a 3 or a 5? Or means that addition rule. So it's going to be 1 out of 6 plus 1 out of 6 minus what they share in common. Can you roll a 3 and a 5 at the same time? And of course, with one dice, of course, you cannot. So this probability here is 2 out of 6. Or you can simplify that to 1/3 if you wish. So let's work on this other example. What's the probability of picking a red card or a number 5? So let's go with red card being A. We'll just define that as A. So the probability of rolling a red card is 1/2. There's either red cards or black cards. We're going to put this out of 52 because there's 52 cards in a deck of cards. 52. Rolling a 5, let's call that event B. So the probability of B, we know that there's 4 cards, number 5 cards in a standard deck. So 4 out of 52. So to calculate the probability of A red card, or a 5 card showing, uses this formula, the probability of A plus the probability of B minus what they share in common. So the probability of A, as we've listed out, 26 out of 52. The probability of B, 4 out of 52. What they share in common. Out of these red cards, there are going to be 2 5s. There's going to be a 5 of hearts, and there's going to be a 5 of diamonds. Under all of the 5s, we would have the 5 of clubs, 5 of spades, but we'd also have 5 of hearts and 5 of diamonds. So those 2 cards appear twice, which is why we have to subtract them out, because those red 5s, in essence, these are here, red 5s, they are being counted twice. So that's why you have to subtract them out once, so we don't double count. So this becomes a total answer of 28 out of 52. So the law of probability, you add the probabilities together, subtracting out what they share in common. Now we can go into another law of probability called the multiplication rule. The probability of 2 events can be multiplied only if, let's highlight this, only if the 2 events are independent. So let's make sure we all remember this. So only if they're independent. What events are always independent? We talked about this beginning of this chapter. Coins, dice, and cards are always independent. With cards, let's just put a little qualifier there. The cards have to be with replacement. Say if I were to ask you what's the probability of picking an ace out of the cards, and you pick one card, probability is 4 out of 52. What's the probability of picking another ace out of that same deck of cards? If the card goes back, the card that you picked goes back into it, then those events are independent. So the cards have to be replaced into that standard deck. So these 3 things, coins, dice, and cards, are always independent. Anything else has to be specified in the question that they are independent for us to continue with this multiplication rule. So it's read as the keyword here is and. It has this upside down symbol. Basically that'll be read as, what is the probability of A and B occurring? We basically take the probability of A, multiply it by the probability of B. This and probability, this is the same as the joint probability, the intersection, as we talked about earlier in this the videos, and it's also the same as what we need to subtract out in our addition rule right in here. So that is the same as what we are seeing in this example, in this multiplication rule. So time is running out on my limit, so we will come back in the next video and go over some examples of the multiplication rule.